Rohan Parikh is the former head of sustainability at Infosys, where he architected the foundational net zero strategy for its unreasonable goals, saving the company over $240 million. After proving sustainability is profitable, his mission expanded to shaping India's solar open access policy. He is a co-inventor of a patented radiant cooling system and holds a master's in civil engineering from the University of Illinois at Urbana-Champaign. The founder of the Stanford BDLA, Peter Rumsey, sadly couldn't make it, but he is honored to have Rohan present today. Please join me in welcoming Rohan Parikh.
Yeah, so thank you very much, Lindsay, for the introduction. I'm really happy to be here. Peter is a mentor to me, and I'm glad that I'm giving a talk here. Uh, I just want to understand who the audience today is, how many people have joined in. So I okay, we have 13 participants. So what I'll do is I'll jump right in, and I'd like to make this a conversational thing. This whole presentation today is more of a personal story about how we went about the decarbonization story at Infosys. And so I was working at Infosys um, in a very boring role. It was more pre-sales and was doing things, and I had a passion in renewable energy. So I decided one day that I'm going to quit. And when I quit Infosys, I sent out an email to the founders. And I was working. I decided to pursue a career in renewable energy at that point. So just to see how that pans out, what I did is I gave a lecture to the facilities team at Infosys, and intern from Stanford was attending there, and she was doing a project at Infosys on carbon footprinting. And when she heard my lecture, she came, met me, and said, "Listen, Rohan, I have no idea about what is carbon footprint, but I can take probably a lot of the slides that you have presented here for my internship." And so, I kind of spent the next 15, 20 days helping her through her project. And when she presented that to one of the founders of Infosys for whom she was working, she gave a lot of the credit to me. And so I was invited over for lunch with this founder. And over the lunch, they found out I have a background in civil engineering. And so that, oh, we should really get this guy on board. And during that lunch, I told them that, the buildings that Infosys is designing are very iconic, but they're not sustainable, right? And I didn't think that would lead to anything, but suddenly, this founder comes up to me and says, "By the way, that's a very interesting statement that you made. Why don't you come and tell us what changes we should make? What is it that we should do differently?" And they gave me 3 weeks because the founder was traveling, and they said that after 3 weeks, come and tell us what you should do. So now I had no idea about sustainability, but I just used that word. And now I had 3 weeks, and I had never met founders of Infosys before. So now I thought this is an amazing opportunity. Let me go and think about what they will think. And so I tried to do a lot of research on Google, and I had personally had no background in sustainability. So I came up with these three goals that today are very, very popular, are there in every single sustainability report of every company in the world. That has become carbon neutral, water positive, and no waste to the landfill, right? And when I presented those goals to the founders, this is 2007. So I want to just give you a perspective. At that point, nobody was talking about these goals. And so they challenged me, said, this is just quite unbelievable. And of course, I had some slides supporting those goals. But everything was borrowed and everything was researched from Google. There was nothing original from myself, right? And so they told me that this is unbelievable. The way you presented it, clearly you have a passion in this. What are you doing? I mean, at Infosys, and how can we get you to come? And everything that you presented, we would like you to implement at Infosys. Are you open to taking up the challenge? So then I had to be honest with them. I said, "Well, I'm very flattered that you're giving me a role out here, But I have a background in buildings because I'm a structural engineer, but I have no background in sustainability per se. And everything that I presented today was borrowed from Google. And they said, doesn't matter, we're willing to take the risk behind you. You've come up with such unreasonable goals. And if you are able to deliver even 50% of that, we would be very proud. And we would definitely like to be the world's leading company on sustainability. So I kind of asked them that, why would you do that? If you have to achieve this kind of goals, you're an IT company, that would entail a lot of risk taking. And then one thing I heard from them, which is, has stayed with me, he says, the founders told me that, see, the most successful people on earth have the highest risk taking ability. So if you think we are a successful IT company and we are successful founders, then we will bet on you. And they actually did bet. And a lot of the story today is about, the kind of risks that Infosys founders took and how we were able to therefore achieve a lot of things. So, India is right now the fastest growing real estate economy in the world. And 40% of India of 2040 is not yet built. So the kind of growth that we are going to see in the next 16 years is going to be alarming. And so just to manage that growth, it's important that buildings that India builds is we are adding 1 billion square feet of new space every year. And if we don't change things, we will go down the China path. I had the experience of seeing China grow from 1995 to 2020. Visited China a few times during that span, and what I noticed is that they had come up with some of the most amazing buildings. Many of them all glass buildings, highly unsustainable. And the reason why I know that is because the Infosys campus in China was consuming 300 units of electricity per square meter per annum, whereas the best buildings in Infosys were doing 70. So they were 4x more. And to power that 4x more, China had to add almost one new coal plant every week, right? And this is something I heard from Emery Lovin. So they were adding so many coal plants, and it is clearly unsustainable, right? When you can do something at one fourth, why spend that kind of money? Because that's a clear waste. Buildings once built last for 50 to 100 years, and so you're locking in the inefficiencies for the future generations to pay for those mistakes that we're making today. And so this has been a very big inspiration in my life of how do you change the country? How do you make the country more efficient? How do you make the country leapfrog? And what we are seeing nowadays in India is that buildings today are getting stranded. And Bangalore, where I stay, is the hub of IT. It's a hub of outsourcing. There are a large number of global capability centers out here, and many of them are Europeans. And Europe has taken a goal of 50% reduction by 2030. So what is happening nowadays is that the European customers are now putting pressure on the developers, saying that either you have to reduce your energy consumption by 50%, or what we have been consuming right now. But none of the customers are willing to pay for it, right? So the developer is kind of caught in a situation where how does he fund the retrofit? Um, Now, what customers have started doing is that if the developer is not taking action, they're just getting out of the lease and signing a lease with a new company or a new developer who's designing the latest buildings with the 50% lower goals, right? So it's very easy for the customers to switch and very difficult for the developers because now they're left with empty buildings. And so this has become a new driver for developers. It's a wake up call for them saying, how do we, if we don't change, we will perish, right? So this has become something that I'm very passionate about, is to teach developers, how to retrofit their buildings or do the buildings right the first time over. And that program that we run right now, we don't charge them, is called Assure. We assure developers that we can help them build, design buildings which are 50% more efficient, and we assure them at no extra cost. And a lot of that, is coming from my experience of what I did at Infosys for so many years. So these are the goals, the unreasonable goals that I took in 2007. And of course, I was not applying for the job, right? And they just offered it to me, and I thought it was very challenging. And so I decided to stay back at Infosys, accept the job, and stay back. But I didn't know how to achieve this. So the next day, the founder kind of, one of the founders, Mr. Narayan Murthy, he invited me to his office and he said that, Rohan, I was very impressed with what you presented, but I also want to tell you that, you need to have data. You made that fancy presentation, but there was no data. But I would like to ask you one thing that and Mr. Murthy used to be very, very passionately involved in designing of all buildings at Infosys, right? And he used to sign almost every drawing from the architects and sign off, and only then it would get built. And so he asked me this question that yesterday you made a statement that Infosys is not very sustainable, and then you made a statement that you can achieve 50% reduction in energy consumption per person. So are you suggesting that I'm so bad? And I was staring at him and I said, sir, this is not a competition. I was not even looking for this job. You've asked me to take this job, and I'm happy to do it. And so he said, Rohan, the way to do this is you have to collect data, because I have learned something that in data I trust, or in God I trust, everybody else brings data. And so the next time we meet, I want you to bring all the data of what is the current performance, right? And so I disappeared for 6 months. I kind of Infosys has very, very large campuses, just like a Stanford campus. They have multiple such campuses across the country. And so what I did is I first looked at the electricity bill and I realized that they had a bill for the whole campus and not for every building. And so then I went and metered every building. When I got metering of the building, I realized there was a lot of energy being used in the nights when there was nobody in the office buildings, right? And so people were leaving their computers on, and so that gave me some insights. But then I wanted to get into more and more details, so I started measuring energy for every system, and then I measured for every equipment. So in a HVAC system, it went down from chillers to every equipment, right? So pumps, cooling towers, chillers, AHUs. Similarly for lighting systems. And at the end of 6 months, I had a fair amount of data, and I went and presented that to the founder, Mr. Murthy. And he looked at the data and he says, "Wow, there's nobody who's come and presented data in such granular manner to me. I'm very impressed. Tomorrow's a board meeting. Um, Tomorrow's the annual board meeting of the company. Can you come and present to the board members?" But before that, just combine your presentation, the first presentation that you made about the unreasonable goals and this presentation about the measurements, combine them and send it to me and to the co-founder Nandan Nilekani, and we'll review it so that we can support you during the presentation. While I was making the presentation, they didn't let me even present one slide. Each one of them presented the entire presentation because they themselves were so proud of whatever the goals that they had taken. And what happened is that the board blessed this presentation and told Mr. Murthy that, Mr. Murthy, these will be your goals, right? So what was my goals became the chairman's goals. And from that point on, it was very magical for me because there was nobody who was going to stop me at that point. So what we felt was unreasonable and what was not possible, we were able to achieve in the first 3 years. So the first building that got delivered in 3 years' time from that was already at 50% lower energy. And I told you my whole journey is more about storytelling. So I was figuring out how will I actually do this, right? How will I really achieve these goals? And I had already seen this 55% reduction. And so, sorry, I had seen that 55% of all the electricity at Infosys was in cooling, and and about 25% was in computing, 15% was, or about 10% was in lighting, and 5% for all the miscellaneous stuff. So cooling was the main criteria. And if I felt that if I eliminated cooling or reduce the cooling energy, then I would win my bet, or I would be successful in what I was trying to do, right? So there was a lot of whys that I was asking, and one such why was landed me into questioning that Carrier invented air conditioning only in 1902, and we use air conditioning for comfort. So what were we doing before that, right? And so I decided saying that let me go. This was, I mentioned to you, annual presentation, annual board meeting was in June, and by that time Bangalore becomes quite cool, and the hottest, places in the north. So I went to Agra, and I went to Agra Fort, which is a large fort, and was trying to figure out, the science behind it. And the tourist guide there told me that in olden days they used to pour water in the channels that were built into this fort and cool the building, and hence people were cooler. And after that Agra Fort, I went to the Taj Mahal, and the tourist guide there told me that the Yamuna River touches the base of the Taj, and it takes away all the heat, right? And I'm like, wow, these two tourist guys have opened my eyes, right? And I'm like, okay, so what are people doing even before these monuments were built, right? People used to live in caves in prehistoric times. And I've been to caves before, and I used to be very nice and cool. So this time I went to Ellora Caves. I went with some kind of a thermocouple to measure. And I was standing very deep inside this cave, and I was trying to figure out why am I feeling so cool, right? And so I had done a lot of research on by then on and I'd figured out that humans are warm-blooded animals. The byproduct of our metabolism is heat. The job of our skin is to constantly give away heat, and and so I was trying to figure out how am I giving away heat in this cave. And I was like, I'm wearing leather shoes, I'm hardly conducting, I'm so deep inside these caves, there's very little air movement, so probably the convection is very low. So potentially all I'm doing is radiating. And I figured out that my body temperature was 36 centigrade or 98 Fahrenheit. The walls were much cooler, and that's what's really happening. And that was the eureka moment for me. Came back very excited, explained this to the chairman of the company, and he said, "Okay, why don't we do this experiment? Let's try this. How are you going to make the walls cooler, right?" And so, of course, I did a very simple experiment. I used to travel the world. I used to see, in Germany, in the US, there was a technology called radiant heating. There used to be pipes inside the bathrooms. Um, and so I said, okay, why don't we do the exact same thing? We put these pipes, connected it to a water cooler, and the experience of people below that was just incredible, right? And so we said, okay, why don't we now take this to a larger level, right? And so we said, okay, well, let's try it in a live building. And of course, I went to my HVAC designer and I asked him that, see, this is an experiment we did, and we would like you to now design the building using this technology. And and I said, listen, I've taken this goal of reducing by 50%, and so you have to participate in that journey with me and help me achieve these goals. And he's like, no, I'm not going to do that. And he resigned. He's like, if you're going to force me to do something which will never work, I don't want to associate myself with it. And you know, I went and told that to the chairman, and the chairman's like, why don't we call him on board? And so he explained that, listen, when you pour cold water in a glass, you get condensation. Rohan was lucky. He did it in summer. There was no condensation happening from the ceiling, and it was an experimental, one room. So I cannot associate myself with this, right? So what Mr. Murthy told him is that, see, there's a new building coming up in Hyderabad. It's 200,000 square feet, and almost all Infosys buildings have a central entrance, right? And so he told him that KV, the HVAC designer's name was KV. So he's like, KV, why don't you design the left half of the building with air conditioning the way you know how to design the best air conditioning technology, and Rohan will design the right half using this experimental technology. And we'll have a 10 rupee bet. 10 rupees like 10 cents. I'm like, what do you, after he left, I'm like, Mr. Chairman, what did you just do? I mean, however, how will I ever design this? I'm a structural engineer. I don't have any idea of how I'm going to design this. As a science experiment, it was okay, but how am I going to design the building? And that's where he connected me to Greg Franta sorry, not Greg Franta, sorry, he connected me to Gil Master at, at Stanford. And Gil Master connected me to Peter Rumsey, right? And Peter then taught me how to do radiant cooled buildings. And it was a massive success. In our very first building, we were able to reduce the energy consumption in air conditioning by 40%. Now, 40% was better than the left half. And since it was a bet, the KV had done a really amazing job on the left half. But overall, compared to all other buildings at Infosys, it was 60% better, right? And like this, we kept on challenging, and asking a lot of whys. And I'll show you a little more, but um, the journey was so profitable, and that's what I'm going to talk a little about, is the effort we made is that we said first we will reduce our energy because renewable energy at that point was very, very expensive. It was almost 2x the cost of the grid if you put up a solar plant. And it wasn't, you know, it was very difficult to even source solar panels in India. This is 2009-10. And so we said our first focus is on efficiency, then renewables, and then we will go for carbon offsets. That's the journey that Infosys took. In 2011, I was asked that when do you think we'll meet the goal of carbon neutrality? And I mean, there was no way that I could come up with a calculation of when. So I said, I gave a far off number. I said, how about 2020? And to my surprise, the CEO went and made that commitment at the UN Assembly that Infosys will reach this number by 2020. And so now there was a tremendous amount of pressure on how we're going to do this, right? So sometimes, pressure really helps because that put all the machinery together. And from that time, the kind of innovations that we were doing with partnerships from, major institutes, some of the innovation ideas came from Stanford, some came from Lawrence Berkeley National Laboratory, some came from NUS, some were our own. But the amount of new ideas that we were able to implement was just crazy because Infosys at that point was adding 20,000 new employees every year into its workforce. And to meet that requirement of 20,000 new employees, I was delivering 2 million square feet of new buildings, uh, approximately about 10 buildings a year. And so we had the opportunity to keep on trying new ideas in every new building that we design, right? And so it was a virtuous cycle of learning something. What worked, we would continue. What didn't work, we would either improve or give up and keep on trying new ideas. We would travel the globe, learn from everyone, get a chance to implement. But the reason why this implementation cycle kept on going is because of the savings. Uh, so from 2008, where the per capita energy consumption was about 300 units of electricity per month, I mean, per year, actually. It's down to 133 now. And I've shown the graph only till 2020 because, since COVID, um, the buildings are not fully occupied, so it's not fair to, show a much lower reduction. But this is what the company has been able to achieve. The per capita electricity consumption went by 55%. Um, if we had not done any reductions, and we had just followed the normal way of how reduction would happen, that's the blue line curve, and the red line is showing. Sorry, the blue line is the reduction that we did, and the red line is really how it would have actually progressed. So we've actually saved 2.36 billion kilowatt hours of electricity in from 2008 to 20. And it was not only the new builds that we were doing, but Infosys also had a stock of 15 million square feet of existing buildings at that point. And so there was a massive retrofit program that was rolled out. And it was rolled out because it was very, very profitable to do this. And I'll talk to you about the profitability numbers in a while. But across the various campuses, Infosys was able to give up 35 megawatts of connected load, extra load, because of, they were able to reduce the energy consumption so dramatically. And so the fixed fee that you pay for, a connected load came down also significantly. Um, we pioneered renewable energy in the country. In 2012, Indonesia changed the price of coal, and overnight, 40,000 megawatts of planned coal projects in India became unviable. 40,000 megawatts. And my blood was boiling. I read this in the newspaper's headline, the Times of India, and I was really, really upset. Was been thinking about it, and when I went to work, it was noticeable on my face that something was bothering me. So the chairman asked me that what's on your mind? Why are you, something is not correct today, right? And I said, sir, I don't know if you read the newspaper, but 40,000 megawatts being controlled by one small country, Indonesia. They are defining the destiny of our country. How can we let this happen? And so he's like, "How are you? What do you want to do?" And I said, "The private sector has to drive changes in the country. It cannot be the government doing things, right?" And Mr. Murthy was also on the board of the UN Foundation. So they had a board meeting about a month later at Infosys. I was asked to present the work I was doing in sustainability, and the board members asked me that if you were given a choice, what would you do? And I said I would get the entire private sector to come together and buy 5% of the electricity, from renewables, and start that journey for the country. And they said this is such a brilliant idea. We have the Earth Summit happening in 2012 in Brazil. Why don't you come and present that idea out there? And so when I presented there, there were lots of corporates who were sitting there. They heard me. They mobilized the World Economic Forum, and together with the World Economic Forum, with the Indian Confederation of Industries in India, NASSCOM is a body of all IT industries. We had a conference at Infosys, and through the power of collective, companies coming together to buy electricity, the signature campaign on that one day, gathered about $1 billion worth of investments. I went to the regulators and I told them that if you let the private sector participate in this journey, we will help change the destiny of a country. We spend $200 billion in energy imports. We need to make some change happen. And you are the guy who writes policies. If you change policies, if you remove some of the unnecessary taxes, if you let us write the policy, we will change the destiny of this country, right? And after 2 years of going and meeting him and discussing this, he actually let us write the policy. And at that point, I mentioned to you the cost of electricity was 2x the cost of grid, but because of the China factor that had happened, the prices were tumbling very fast. And when they let us write the policy, we removed, there were those three charges: wheeling, banking, and cross subsidy. We removed those three charges for 4 years. And what happened after that was very magical. The amount of solar growth that happened in both India and China was just alarming, and the prices kept on tumbling. So when the first project actually got rolled out on this collective buying, the price was actually cheaper than the grid, right? And today, the cost is about 30% lower than the grid in India. And so that journey that started at Infosys, and of course, Infosys pioneered this. And about 70% of all electricity for Infosys comes from renewables. It's not possible to reach 100% today because of policy reasons. Otherwise, we would have been, I mean, they would have been 100% long back. The emissions intensity has gone down by 77%. This is scope one, scope two, and three put together. The per capita water consumption has gone down by 64%. One of the goals that I had taken was also becoming water positive. Um, and since that time, the design of the campuses have changed. Now, in most of these large campuses, Infosys ensures that no drop of water leaves the campus. So all the rainwater gets collected in ponds across the campus, and a lot of that pond water goes into the ground, gets recharged. Some of it is consumed, and a lot of that water is going into the ground. So we are sequestering more water into the ground than what Infosys consumes now. So in some sense, they are actually water positive. Also, the biggest thing was, of course, reduction in the water consumption. Um, Infosys probably has in India one of the largest, plan of, but they have about 30 million square feet, which are LEED US LEED certified, um, and and the journey is just continuing. I mean, since then, this is again up to 2024. Since 2024, also there will be many more buildings which have come into the green building, certification. Now, actually, the certification doesn't really matter because they're doing far more than what the certification expects you to do. But this is the real money impact, right? I want to tell you that the employees from 2008 to 20 grew by 166% in the company, but the actual absolute energy increase was only 20% because of all these efforts. And the cumulative, savings. So if you change a light bulb from an incandescent to an LED, and you save, let's say, $5 this year, over 2 years it's $10, and 3 years it's 15. So if you add that in a cumulative manner, the cumulative saving is $240 million. Now this goes directly to the bottom line. So it is so profitable for the company, and hence this journey, which started in 2008 as a good thing to do, has continued because it is highly, highly profitable. And in my journey, after I left Infosys, I've been able to replicate this for almost every company that I've worked with and every developer that I've helped. I did this for Walmart India. I did this for UPL in India. And I've helped so many developers in India achieve these numbers where their projects are 30 to 40% of 50% lower energy consumption than they were previously, but at no extra capital cost. And a lot of that is because globally, I mean, this is not just an India factor, is engineers tend to over design. So if you optimize and you do the right design, and if you reduce the heat load dramatically, then you get a huge amount of savings. And I'll talk a little about that a little later. So what started, with those unreasonable goals had to translate into unreasonable goals for the design teams. And so we took this, several goals, but there were some which are very interesting, and I'll talk a little about the lighting goals. Um, what I was seeing is that at home I don't use any lighting in the daytime. So why do we need to use lighting in the daytime in the offices, right? And at that point, I had just I'm talking going back to 2007, 8. So this was very early in my goal taking, and I went back to all the architects saying that the next building there's going to be no light because in the end the lighting also adds consumes electricity and adds heat into the floor space, which we need to cool further, spend more electricity. So can we design a building which is say 90 to 100% daylit, but without glare? And I also gave them a goal saying that if you don't achieve that, then we will not pay you your fees. So almost every architect who was working with Infosys resigned, saying if you're going to be so unreasonable, because in architecture we don't take any performance goals, right? And I said, okay, that's fine. I will find another architecture firm which is willing to work with me. But I mentioned to you, right? Infosys was building 2 million square feet every year. So the scale at which we had was very large, and so there were many other architectural firms who said, okay, we don't mind, helping through the design process, but quite honestly, we don't know how to do this. So we also have to learn. And so what we did is we actually set up an in-house team on building simulations and helped many of these architects achieve their goals. And then they came back saying, what does no glare mean? And I said, if anybody in the entire campus or in the entire building asks for window blinds, that means there is glare. And so that's not going to be acceptable. Again, we won't pay your fees for that. So since 2010 or 9, every building at Infosys is 100% daylit and it has no glare. So there are no blinds in those buildings. And so it required a lot of thinking. It required a lot of planning. It required a lot of simulations to achieve this. Similarly, on HVAC, most engineers prior to our team coming on board were designing air conditioning on a thumb rule, or rule of thumb that you may call it. So it was typically 1 ton of air conditioning cooling 300 square feet. And we went back to them and said, no, we would like it to be 750 to 1,000 square feet. Of course, this is something that Peter nudged me to, take as a goal. And so I went back to them and I said, we will like it to be 750 to 1,000. And of course, the first reaction was that's not possible. And these goals are not for the HVAC consultant. These are goals given to the entire design team. And so the architect said, what's the role I have to play? And so we had to tell the architect that you play the biggest role in defining the heat gain because you're designing the facade, you're designing the lighting systems. So you are responsible for a fair amount of the heat load that's coming into the building. And hence, the goals are not just meant for the HVAC consultants. In fact, they have no role to play in the heat load. And it's the whole team, right? And so this kind of integrated design, ensuring that every single person in the team was taking the goals, was a very integral part of how we went about taking this. But till date, no architect has lost their fees. So, meaning which we've achieved everything. This table that I'm showing you about leapfrogging India into into best in class is something that we borrowed from Emery Robins's book Reinventing Fire. And so this gave us a real good benchmark. And sometimes what we feel is that decision makers don't even know what to ask for. If they don't know what to ask for, how are they going to get it? And till date, I've seen that most developers in India, when they are giving specifications to the architectural team, they're talking about the aesthetics, they're talking about the functional requirements, how many square feet per person, what kind of amenities to be provided. Even today, none of the developers are specifying the energy targets. So, and when I asked them why you don't, they said we don't even know what we should aim for. So if you don't even know, how will you achieve it? And so the biggest difference that we can all make together is to make this table very, very popular, make it available to every decision maker. The top management teams at Google, Meta, I'm sure they don't know what to expect, right? So unless this what targets to be taken is known to everybody, we will not be able to change the world. And so this is my focus today, is to ensure that all the developers in India are at least aware of what to aim for. Only if you know what you can aim for, then only you can achieve it, right? So we took these as a benchmark, and we said we have to beat these benchmarks. And so most of our goals were like, how do you beat this? And because we pursued these goals, we were able to show some dramatic changes. Right, the total electrical load came down from 8 watts a square foot, which was, again, there was no basis for 8 watt, but it was a standard practice saying that IT companies require a lot of electricity. They require a lot of comfort, cooling, and hence this was a thumb rule of 8 watts per square foot. And so through our design process, we were able to bring it down to 4 watts per square foot, but the actual consumption is only 2.9. The peak actual consumption in Infosys buildings is 2.9. So even 4 is an over design. So that is the kind of over design that is there in buildings, right? And similarly, if the electrical load comes down, the transformer capacity comes down, the DG set capacity comes down, the HVAC capacity comes down. We change the lighting, standards. We optimize the structural engineering dramatically. And so when we added up all of these savings, the capex savings was about 10% of the construction cost. And so we use that savings to design better envelopes, buy the best glass that money could buy, right? Invest the money in better, in more efficient equipments. So there was no extra spend. It was just the money saving from MEP, mechanical, electrical, plumbing, that was, being used for the facade and for buying the most efficient equipments. And that formula has worked for us across every building that I've been designing over the last 18 years. Um, the savings in electricity per square foot is equal to 1 month's rent. So again, it's very profitable for every occupier, right, to support this. Um, This is what I mentioned to you about. We use simulation tools. The building on the bottom left was a rectangular building. After doing the simulations, we kind of created a internal courtyard, and the whole building became daylit. And so since then, what we've seen is this is an H or an I-shaped building. So almost all Infosys buildings became alphabetical, right? They were either E-shaped building or an F-shaped building or a H, I, B, D, all of those kind of shapes. But what I'm trying to say is very thin floor plates, and that became the norm of how buildings were designed. And even today, that's how buildings are being designed today. They're 100% daylit because of this reason. Um, what we also did is from Lawrence Berkeley National Lab, we learned about light shelves. We integrated light shelves in all our buildings. You can see the building on the bottom, the internal space on the bottom right. There are no lights which are switched on, and they are not switched on throughout the year. So from pretty much from 8 a.m. Or 9 a.m. to 5 p.m., people work in daylight. They also feel good and nice about working in daylight. Um, we have not only light shelves, but we have vertical shelves to cut off the glare that can come into the buildings. So these are the strategies that, kind of course, I'm, just touching on the surface. Um, uh, Lawrence Berkeley National Lab played a very, very important role here. They guided us through the designs of, the light shelf. They guided us on how to implement it. And so again, hats off to the US and the large institutions and the large labs, national labs that you have, and the fact that you're giving away so much knowledge really makes a difference to, different people in different parts of the world. Today, many of these ideas have been taken, which Infosys has implemented, have been adopted by many other companies, and so there's a fairly large impact that knowledge sharing can accomplish. We implemented a lot of optimization strategies for lighting and for HVAC. The first part was, of course, passive designs um, and our daylighting strategies I spoke about. Even the artificial lighting was done using simulation. We were using the most efficient fixtures. Today, 160 lumens per watt is a bare minimum that is being used in most, and that's why you're able to achieve the zero point 0.3 watts per square foot LPD. And everything is controls, right? So based on the amount of light coming in, the dimming controls work that way. Um, and on the HVAC side, of course, the first focus was to reduce heat gain. There was a there was a massive focus on that. In India, the thinking was that, insulation is only used in cold climates, right? And so we had to change that mindset. Based on the simulations, we were able to, select the right kind of equipments, the right sizing of the equipments. We were able to choose the right systems, efficient systems like radiant cooling. We had amazing control strategies and continuous monitoring, right? And this continuous monitoring has gone a long way because we are not only monitoring the energy performance, but we are also monitoring the performance of all the sensors, and are able to figure out which sensors are malfunctioning. And so because of that, we are on top of the game at Infosys. They have been able to maintain and collect the cleanest data over 30, now sorry, 50 million square feet. So they have the best database of high performing buildings in the world, probably across so many different climate zones, across so many different occupancy levels. So very interesting. What Infosys did do is share some of its data with the Bureau of Energy Efficiency in 2010, and that data helped shape uh, some of the targets that were given in the ECBC code, the Energy Conservation Building Code, that was published in India. So again, data really helps change policies. It helps people because it was such clean data. They were able to use that in policy making in India. This I explained to you, the whole radiant cooling strategy of ours. So I'm not going to talk about it. This is something that Peter Ramsey showed me, and that is what convinced me. This is when I was visiting Stanford in 2007 or eight. This is what he taught me about, why radiant cooling is so efficient. One cup of water is equal can carry the same amount of heat as these two bags can carry. This is the same photograph he showed me, which I've kept it, and I use it in all my lectures. So that struck me that water is 3,400 times more heat carrying capacity and it's abundantly available. So why not use water and why not use radiant cooling to do heat transfer? But also the air, right? Since we don't use air at all, so instead of pumping large air through large ducts, we are using water that is being pumped. So the pumping energy came down also quite significantly. Um, and then the chiller, because we were not cooling it, in India, we for air conditioning we have to take the water down to 7 degrees, but in radiant only to 16 degrees. So for every 1 degree that you don't cool, the lift that you reduce, you had a 3 to 4%, I'm sorry, 2 to 3% savings. So the combination of both the pumping energy and the chiller energy was more than 40% savings, which I spoke about. These are some of the photographs of radiant baffles that Infosys actually went ahead and patented it. They patented it so that others can use it and nobody can stop others from using it. So even though they've patented it, they want everybody to use it. So water flows through these baffles, chilled water at 16 degrees, and humans, as humans, we radiate our body heat to these cooler baffles, and we have incredible cooling in at Infosys. There are no hot spots. Managing the comfort with air is an art, and that art is missing right now. Air balancing is really missing, and in radiant buildings, what we see is we don't get any complaints. So it's been transformative actually to use radiant cooling, because not only is it more efficient, but it's also better in terms of cooling. It's more even. The building envelope, the glass, nothing picks up heat. The mean radiant temperature of the entire floor comes down, and as a result, all of us feel more comfortable. Um, Now, this is what I was really talking about. That controlling the heat gain by using the best insulation, better lighting, the the best computers, right? It became a massive procurement strategy for Infosys to while they were choosing computers and laptops. The biggest criteria there was, okay, when you're comparing two companies, almost let's say an HP or a Dell, and you're comparing, you'll choose the computer which has lower energy. And of course, since 2008, 9 to now, things have changed dramatically. Computers have become much more efficient. Everybody's shifted to laptops. So from 100 watts or maybe 150 watts of energy per system, now we've gone down to like maybe say 30, 40. And most times computers are not on. You are reading emails or reading something, so they're not processing. So the energy consumption is even lower, right? So the lesser heat load in a building meant smaller chillers, smaller pumps, smaller cooling towers, smaller plant room buildings, smaller pipes, lesser insulation, smaller AHUs, smaller transformers, smaller DG sets, smaller cables, and all of that savings is therefore used. The 200-300 rupees a square foot for a million square feet is a lot of money that can be used for making buildings with better envelopes. And this has been repeated now across millions and millions of square feet. And there is so much data that is available for developers to actually take and use that data. And we could potentially even share that data for, because this data is applicable across the world, right? It is not just for Indian buildings, right? The same strategy is the same, but people need data. And so I'm sure, Stanford can work with Infosys to collect all this data and maybe publish it. If Stanford publishes it, the whole world will look at it. And if the whole world will look at it, will drive a bigger change, because then everybody knows what goals to take. So maybe there is a way to collaborate to make a difference to the world. These are some of the buildings and how they look at Infosys. So they're not 100% glass buildings anymore, but they're still nicer looking buildings. Um, um, Before I stop, I want to stress about this building management system. They have a active central command team. This team watches alarms across all campuses, across all geographies. So they have so much data, and there is somebody watching the alarms and fixing it. And this is the key. Sensors tend to drift. Things do tend to go wrong. A VAV box can fail. Motors can fail. Small motors can fail, and so things can go wrong. And so unless we have access to data and alarms, And unless we are on top of the game and ensuring that the sensors are all calibrated and working properly, it is very difficult to trust the building management system. And so my experience globally has been that building management systems really truly do not deliver what the promises. And it's not the fault of the building management system or the sensors. It's really the fault of the person operating it. They don't pay attention to it. They don't diagnose the faults and address it, right? And so if you don't diagnose the faults and if you don't address it, and it compounds, and at that point, when they start getting more and more complaints, because garbage in is garbage out, and you start getting complaints, you lose faith in the system, and you give up on it, right? So what have we done? I mean, we've taken this last 20 years of learning, um, and what Infosys done is created a program called the Assure program. Assure actually is an acronym for Accelerating Super Efficient Sustainable Real Estate. And we in this program we offer our services free to all developers across the country. Today, some of the largest names in the world, Blackstone and Brookfield are the largest developers in India. Both have signed up on the Assure program. Blackstone for retrofits, Brookfield for new build and retrofits, right? And some of the other larger developer brands in India have pretty much signed up with Assure program, to learn from the experience of Infosys. Infosys is actively contributing. What they do is they invite all the large developers to come to their campuses. They walk them through all the energy systems. They walk them through all the goals. They tell them how they've done it. And some of us who have left Infosys are guiding these developers on a regular basis, meaning we participate in every design charrette of theirs. We participate in every bi-monthly meeting of theirs. We guide the design teams on what kind of strategies to adopt. Personally, because we've done so much, we've built so much and delivered so many buildings, we have the pulse of what works and doesn't work. We can identify by intuition what works and doesn't work in a design. And then we are able to back it up with simulations and data. So this is driving a massive change. One change, though, that I'm very excited about is just like the solar policy. I personally believe that green building should become a policy mandate. Today, it's a good thing to do. It is not a mandate. Um, and if it doesn't become a mandate, then the adoption levels are not going to be very high. And my worry is that India is building so much, is the fastest growing real estate economy, but the awareness of what is possible and how it can be done is still not there. It's not widespread. It hasn't spread to everybody. There is a lot of good news also, though, that the whole industry itself is changing. There's more and more renewable energy penetration happening. Similarly, EVs are transforming, like renewable energy is transforming the electricity sector. EVs are transforming the transportation sector. And now, what we are seeing through a lot of our work that we're doing is heat pumps, and especially high temperature heat pumps, which is like 130 centigrade, or maybe closer to 275 Fahrenheit, is now possible, and that will decarbonize industries. So the combination of electricity sector, the transportation sector, and industrial sector will decarbonize the world very fast. So from that perspective, there's a lot of hope. While while I do feel the buildings are not adopting the technologies at the pace that we feel they should, maybe there is a synergy between Stanford and Infosys to make this data available to many more, and help everybody else in the transition journey, especially if it doesn't cost more, right? So I'm going to stop here. I know it's been a long monologue from my side, and I'm happy to take questions.
There's no questions in the Q&A section, so if anyone would like to ask a question in person, you could raise your hand and I can unmute you. Okay, here's one.
Hi, Mr. Parikh. Thank you for the presentation. Can you hear me?
Yes, I can.
I was just wondering what if you could talk about what specific features the architect kind of collaborated on for the design of the buildings with for like daylit and no glare features. I'm not sure if you already covered that, but yeah, it would be really cool to see
Yeah.
and like talk about what your favorite features were and like the most innovative.
Yeah, so the first is, I mentioned a little earlier, was the building floor plate, right? The building floor plate in all projects that we design are limited to maximum 20 meters or closer to 60 feet. They're actually more 50 feet to 60 feet. And so most of these buildings are kind of shaped, alphabet shapes, right? H or I or E or F. And many such buildings are, have been built by me or designed by me or with the help of many architects. And it's fascinating looking buildings. So one is that if it's a narrow floor plate, and a lot of these buildings are perfectly north-south oriented, right? So it's easier to tackle the glare. On the east-west, if you see in this particular building, the East West has rooms, which are the conference rooms or the cabins for managers. But the floor space is where all the workers are, and they are completely open. They face mainly the north and south, and it's very easy to control glare, specifically on the north, but even on the south by putting light shelves and uh, vertical louvers. So these are the major strategies that we've used to achieve 100% daylit buildings with no glare. This is one of the projects that I showed. Did I answer your question? Or?
Yes, thank you so much.
Okay, then there's someone who's the next.
Sure.
Yeah, this is Dave Martinez. I was wondering, can you talk a little more about the beams, the chill beam type system? Is that free airflow across, or is it more like a heat system or a Venturi type uh, system? Yeah,
So this is
curious.
this is how the false ceiling looks like, right? This is
Yeah,
a false ceiling at an Infosys building. The in the center you see, the sound absorbing panels from and on both sides of the sound absorbing panels is this vertical baffles. These are aluminum baffles. They are like fins, and in the center of those fins, water is flowing through them. Right? It's like a radiator fin, and water is flowing through them. So a 16-degree water flows through them, picks up the heat from the room, and when it comes back into the air conditioning system in the chiller, it leaves at 16 from the chiller, returns back at around 21. So there's a 5-degree delta T. That 5 degrees is what it picks up from the room. And so it picks up the heat from the people, from the computers, any solar heat gain that is coming in. So all of the sensible heat is picked up by these baffles. The temperature of the baffles is about 16 degrees. And if you see, because they're baffles, the air in between these aluminum fins also cools down, and so that starts a passive convection system. So that cold air between the baffle, the air cools down, and it becomes heavier and falls down, and the hotter air comes up. So it's a combination of both radiation. Typically, we are trying to cool people, right? So it's the humans which are radiating the heat. Each one of us is about 140 watts. About of that, about let's say 80 watts is sensible heat, right? And so that heat we are radiating into to the baffles, and we are feeling nicer and cooler. Of course, all the other objects in the room are also radiating that heat to these baffles. So the all the objects around you become cooler, and therefore, the human body generally gives out bulk of its heat through radiation, and this technology enhances that radiation, and hence we feel very cool. Um,
thank you.
so Yeah, it's not a chilled beam.
No, no,
The
exactly.
air that is there, that is coming, the fresh air that is coming in, that gets dehumidified before it enters, and that is the air that is required to take the moisture that people introduce while talking and breathing. So that's the
Okay.
only moisture that is entering the room, which needs to be taken away through the dehumidified fresh air that is introduced.
I was wondering about that, how you handle the humidity. So thank you.
Yeah. So 70% let's say, yeah, 70% of the heat load is taken through the baffles and 30% through fresh air.
Thank you.
Do you have time for one or two more questions? There are now two questions left, but
Yeah,
we
I
can
have the
end.
time.
We can
No,
end.
I have the time. I'd be happy
Okay.
to take questions.
Okay. I've presented life cycle cost analysis showing long-term savings from energy efficient building design, but leadership hasn't approved the higher upfront investment. How can I convince finance to prioritize these sustainability improvements?
Right. So, in my experience, and specifically in India, um, I can tell you that um, all the buildings that we are designing, high performing buildings, the amount that you save through the effort of optimization is so high that the capital cost reduces in most of these buildings. And then what we do is that whatever we have reduced over a standard building that was built before, all that reduction is therefore given to the architecture team to improve the facade, make it better, make it a high performing facade, the best, buying the best glass that money can buy, and invested in buying more efficient equipment. So we are actually taking money from one pocket and giving it to the other pocket, right? We are not spending more. We are saving through design, and whatever the saving is there is then used. um, but that discipline has to be there. The developer cannot say, no, all the savings is mine and I will not invest it in the envelope. Then you cannot manage, then you cannot make a high performing building. And that does happen too. I mean, there are some developers who will take all the savings but will not in optimization but will not invest it back. But most of the customers are mature. They understand that as long as the previous budget of the previous building is not exceeded, I'm happy to spend that. They've also now realized that uh, I mentioned to you earlier that if they don't upgrade or if they don't build a building which is designed for 20 years from now, the newer buildings will become more efficient, and because of the pressure of becoming carbon neutral by most large corporates, they will move away from your building. And so the fear of stranded assets is really adding helping design teams, because now the management is very open to making those decisions to make the buildings more efficient, while we are teaching them strategies of how even though it's more efficient, it doesn't cost more. The economics may be different in another country, but certainly in India, I have experience of 50 million or maybe even more, where we've been able to show with data, with actual performance data and with actual cost data, that it doesn't cost more.
Um, what are a few strategies, or what are a few strategies that have been most helpful to avoid condensation forming in troubling quantities on cooling fins in regions with, oh, I think you might have covered this, but in hot and humid climates.
Yeah, so I did cover it. One important thing to recognize is that the humidity, the buildings nowadays, the building construction has improved so dramatically that the buildings are fairly airtight. So there is no external humidity introduced into the building at all, right? Except for the entrance level. That's where people can come in and out of the building, and you can potentially. So what we do is that the entire entrance lobby and the ground floor where the people are coming in, that is air conditioned. So we don't let any humidity enter the building, and the only humidity that is introduced inside the building is from people while talking and breathing, and that is handled by. So it doesn't matter whether it's hot and humid, dry, or this thing. It doesn't matter which part of the world it is. Radiant cooling will work in an airtight building, and the fresh air is taking care of the humidity introduced by people. That's the only humidity that is coming in through people.
Okay. We are developing fully redundant modular air handlers with a maximum of 1 inch internal pressure drop. Would this help you with your energy efficiency progress?
Yes, of course. So what we do is In all the air handling units, the velocity is dramatically reduced, or the air velocity. So the AHU coil size, the face of the coil is designed fairly large, and typically, the design standards earlier were 500 FPS, and what we design is at 250 FPS. So the water moving across the air moving across the coil is so slow that is pretty much laminar. Now, what happens because of that is that the water droplets form around the coil, and if the air is blowing very fast, they will fall off. But if the air flows very slowly across the coils, then the water droplets remain around the coils and they increase the surface area of the coils. And as a result, the heat transfer is much better. And so the best strategy for reducing both the pressure drop and the uh, improve the efficiency of the AHU, what I have seen is to reduce the velocity of the air flowing across the coils. Of course, that means a larger AHU and a little more expensive, but the payback is almost less than 1 year for such a strategy. However, because we are saving so much in the overall reduction in the heat load and all of the other strategies, we are able to afford a larger AHU.
Okay, last one. What percent of projects are new construction and what percent of are existing building transformation? And for those buildings that get a retrofit, what is the process for determining the cost benefit and risk associated with retrofits, building transformation projects?
So I'll give you statistics of India, which is what I know. Uh, India, and I'm giving you statistics more from a commercial office building, which is my area of expertise. Um, Although India is adding about 1 billion square feet of new build space every year, uh, about 10% of that is commercial office buildings. And so that's, let's say, 100 million. Now, the existing stock of grade A office spaces is 1 billion. Okay. And we are adding 100 million every year. So there is a massive, massive need for retrofits. Now, retrofits is a very difficult strategy. And what we have seen now is working very well or is picking up is the ESCO model, energy as a service model, where an expert comes in, takes over the utilities from the developer, retrofits it with the latest technology, designs it well, operates it at the most optimum. They're able to manage the proper algorithms, maintain the systems, and so the systems deliver, as per the OEM specs. And so the energy as a service is transforming the market. It's still very small, but uh, all the players who have come into the market have more business than they can handle. So potentially, maybe that might be the way to solve the problem for retrofits. New build, of course, if you get it right from the first place, it is cheaper to do it. So why not? I hope I've answered the question.
Yes, so thank you so much. And thank you all for attending today. Make sure to check out the website at bdla.stanford.edu for materials and future events. And again, thank you, Rohan.
Most welcome. Have a great day.